Okay, so we've been able to argue that this Pythagorean trigonometry identity is true for all values of theta in the range of 0 to 90. So the square of the sum of cosine and sine is 1 for all angles in the range 0 to 90. We can actually extrapolate that to all angles using the definition we talked about in the first video when we talk about defining cosine sine as a point, as the coordinates of a point as it moves around as a unit circle. This definition is useful for such things. So remember that we said when the angle was theta, the coordinates of this point were cosine theta and sine theta. And you know, for an example, let's move that point to an angle of about 135 degrees, let's say. So the angle is like this. And the coordinates of this must still be cos theta sine theta, where angle theta is now bigger than 90. But it doesn't really matter. You can see, you know, there is a right angle triangle we can draw here, such that this is 1. This distance is cosine theta, which is negative. This distance is sine theta, but it should still work out. It should still square to give 1 because of the Pythagorean theorem installed in the setting. Okay, and you can check that. Cos of 135 degrees will give you minus root 2 over 2. Okay, and squaring that will give you, you know, 2 over 4, or a half. And squaring the sine of 135 is also a half, and adding these two halves will give 1. So this identity will remain true no matter what the angle is. So it's true for all values of theta, which is pretty interesting. And then there's also two different versions of this identity that you get by dividing through by cos squared and sine squared. So just suppose I was to divide through by cos squared. Each term is now going to be divided by cos squared. So I will get 1 plus, now sine over cos is tan. So sine squared over cos squared is tan squared. And this is sec squared, because 1 over cos is sec. It's a third letter. It's important. Okay, so 1 plus tan squared is sec squared. And the other variation of that identity, of course, you get by dividing by sine squared, right? And once we do that, we will get, so cot squared will appear over here this time. Plus 1 equals, well, is equivalent to, I guess, cosec squared. So those are the other two forms of this Pythagorean identity involving, you know, the other trigonometric functions. So we can cover all 6 functions using this. And this identity will come up again and again in multiple settings, so it's really important that you get your head around it and get really familiar with it, understand why it's true, and just take it as a plain basic fact as we move forward in this building process.